Hello and welcome to AnyLogic webinar, Multimethod Modeling with a Customer Satisfaction Scenario. My name is Arash Madavi and I will be your host today. Let's begin by noting some housekeeping items. If you cannot see me at this time, please click on the video icon on your GoToWebinar menu panel. You can submit questions at any time through the Questions tab on your menu panel. We will address questions at the end of the webinar. For efficiency purposes, we recorded the model building, which I will walk you through today. And don't worry, we will include every step, plus you will receive the recorded webinar, model source code, and step-by-step instruction within a few days. In order for you to better understand the application of the model and how it works, I'm going through an overview of the model and how it works, the model detail. So in this model, we are modeling a service provider, an example, the internet service provider that is servicing 300 users. The service provider operates a service that is subject to interruption, downtime, or similar. And when the service is interrupted, the user will submit a request for the service to be restored. Service provider has a distributed section inside its design that handles those requests. The users will be modeled as agents that send requests to the service provider, and whenever the service provider handles that issue, it will send back a message to the user saying that the service is restored and you can move on using it now. So this is the overview of how the service provider and agents, the service provider and the users are communicating with each other. As we said, this is going to be a multi-method model. We have agents, we have a service provider that has a descriptive and construct in it, and users or our agents will have two built-in or internal construct, which will be a Statechart plus a system dynamics that models the SE agent behavior or agent interaction. The users are more like agents. Each user has individual behavior and attitude towards service, which is modeled by a Statechart. And the users have a varying level of satisfaction for the service based on service performance captured by system dynamics flow. The users can interact with each other and share the experience with the service. So there will be some message passing between the users, and the model shows the impact of the capacity of the service provider on how many of the users will be satisfied or frustrated with the service at the end of the model. So let's move into the model building process and see how we can achieve this goal through a model. The first step that we're going to is going to creating a new model. There's a very simple wizard here. You name your model. In this case, it's going to be user satisfaction. We have access to our model unit time, which is going to be minutes. We finish here. We have a new model ready for us to start building the model. In the project view, you can see different parts of the model, and we have a palette view that we can start building. So in the palette view, we start by building a population of agents. We go through this filter. The agent type would be the user, and the population would be user, which is automatically generated for you. We need to choose the animation for it, a 2D person icon would be chosen, and we have just one parameter inside this agent called base loyalty of type double that has the default value of 0.1. We go to the next part of the user, and we create 300 of these users now. Now we are configuring the environment. It's going to be a 400 by 400 pixel presentation, and we have a random layout for those pages. If you so we can see the presentation of one of those population on the main menu, and we're going to move it a little bit to the right, so the population will be a little bit centered, and we can draw agent with observation. If I run the model now, you can see that we have 300 agents with that person icon at the presentation laid out randomly in the interface. We go now inside the user agent, click on the icon. It's just a trick to make the color of that user accessible during the runtime. And if we delete the default person group added to it, and now we have access to all the internal part of that icon. If you want to change the field color of it to blue, okay, if we run the model again now, we can see that those icons are in blue. So we have a population of users. The next step would be to adding a state chart inside the agent user. We go to inside the user agent, and we go to the state chart palette. Each state chart has to start with a state chart entry point. Then we are going to define the main state of how the service would be in. These two main states are going to be using and frustrated, based on if the user is able to use the service at that time, or if it's not working and the user became frustrated with it. So we change the names. We can change the colors to differentiate it a little bit, but these are just static changes. The using state would be a compound state. There are two simple states inside it. When you put a simple state inside the other state, the other state becomes a compound state automatically. We need an initial state pointer for the internal state as well, which is connected to the working state. We have two internal states inside the using state called using and waiting. Change the colors. The next step would be to define how we how the transition between these states works. So for that, we are using this transition elements from the Statechart palette. There are two transitions between the working and waiting states, going from working to waiting and vice versa. The first one would be if there's an issue. We're going from the working to waiting state. It's going to be a rate of 1 per minute. And we come back from waiting to working if the issue is resolved. It's going to be triggered by a message that you're not going to finish at this time. Just define it, but it's not going to work. We haven't assigned any message in action. The next transition would be between the compound state of using people state of frustrated. There will be two transitions similar to what we had. These two will be called substrate. When somebody is frustrated and by some means become happy or accept the service again and come back to be a user. And the second one would be when you are using the service, but because your service is down for a long time, you become frustrated and you feel frustrated. And we call it give up. And it's going to be a condition. Both of these two conditions are set to false, so the subscribe and give up will not work at this time. They're both conditions are false, so they never be activated. In the using state, the entry action would be to change the color of the user, the person icon, to show us if in which state we are. So if we are in the using state, we set the view color of the person icon to be blue. We have the same logic and same line of code, very similar one, set the color of the person icon to red when we are in the frustrated state. So we can visually see during the simulation in which state they is. We can go and see inside each agent because the transitions between the using and frustrated is not working yet. We never go to a frustrated state. So we are always in the using state, and we go from working to waiting, and because we are always in the using state for all the agents, all of them will remain blue at this time. So in the next stage, we are going to add a system dynamic construct to capture the satisfaction level of agent in the service. We have another palette dedicated to system dynamics, and we start by adding a new block and new spot. We call it satisfaction. You can make lots of changes to this visual based on more representative of what you do. And we are adding 3 flows to this stuff. So we have 2 inflows and 1 outflow. Just move the pieces of code around each other. And the first inflow would be the satisfaction of gain. It adds to our satisfaction level. We can change the color of that flow and move its name, make it more clear. So we have another outflow called loss due to waiting, and we change the color as well. And we have another inflow called gain based on royal gain. Now we want to make some connection between the states of the Statechart and how these flows, the rate of these flows work. So we look into the Statechart and we say if we are in the working state, the inflow rate to the satisfaction start would be 1 per minute. So just keep in mind this is going to be a continuous flow. So this is linked to the working. Loss due to waiting, outflow would be linked to when you're in the state of waiting. So it's going to be the same thing. It's going to be 1 per minute if you're in the waiting state, or 0 if you're not. And so this is connected to that waiting chart state. And the loyalty gain inflow is dependent on the using state. Regardless of you being in the working or waiting state, you gain 0.1 for base loyalty, which is 0.1 per minute. So as you can see, there is a small icon here that says that you haven't used that, and we create a link automatically by clicking on that. The error in AnyLogic automatically uses as a link between the base the parameter. So the next step would be to connect the transition between the using and frustrated state to the satisfaction level in the system dynamics. So if our satisfaction level is above 0, we are in frustrated state, we go back to the using state. And if our satisfaction level becomes minus 10 or less, we move into the frustrated state. And now we have a complete link between the system dynamic part and the Statechart. If we move inside an agent, one of the agents, you can see the satisfaction level will change. Because we're in the waiting state, it's going to be minus 1 per minute, and it eventually goes to the satisfaction of minus 10, and it moves into a frustrated level. And it happens to all of our users because we do not have any mechanism to deal with the down services yet. So everybody will go to the waiting state, their service is down, and we haven't added anything from the model to handle their request for their service to be restored. So now we're going to add a request agent that handles the request part from the agent to the process of handling the message in the service level. So we add just an agent type. We do not have any representation of the request in the model. We call it request. It doesn't have any animation. It only has one parameter. We call user of type user, which is our agent type. So the request knows which user has sent that request. So because of that parameter inside the request records which user has requested the service to be restored. Now we are moving to the request handling process, which is going to be done through the discrete event type of process model. In our process modeling library, we start with adding an enter block. Then we have a queue, which queues the requests that are not handled yet. And we have a delay, which captures the timing of that. In the enter block, we say that agents are devoting to the block of type request. The queue will have a maximum capacity, so we can have as many requests as we want. The delay time of handling each request would be a triangular solution with unit of minutes. And we have the capacity of 60 in this delay, which shows that we can handle 60 requests in parallel. And at the end, we have a sync being able to resolve. And then we have a request that reached this resolve part of the process. We send a message, or we make the user receive a message which is going to be a string of completed. And this string will be passed to the user, and here this string will be evaluated, and if we receive a completed message from the process of process, we know that this agent is, the service of this agent is working now, and we go back to working state. Here we are adding how a new request will be built, and whenever we go from, we are inside this transition, we build a new request and we send this request, we put this agent inside that request, and we send it to the enter block in the main agent, and that request will enter in this enter block and will process in the process. Now if we run the model now, we see that those requests are coming from the users and are going through the process of request handling. And if we go into specific users, you can see that when you're in the waiting, some of them are going into the frustrated state, but but some of them, their request will be handled on time, and they go back between the working and the waiting state during the simulation. So if you go into the frustrated state, you stay there forever because we do not have any mechanism to get back a frustrated user yet. Just before going into that part of the model, we add some representation or presentations to the model to be able to analyze the outputs of the simulation a little bit better. If you click on the simulation window, you can see this frame. We just make it a little bit bigger so we have more space during the runtime for adding a new chart, which would be two charts on top of each other. And we are going to add a view chart here inside the agent, and it's going to be aligned on the top left and zoom to the left. We resize it to be exactly the same as the frame in the simulation window, 1000 by 700. And as you can see, it's exactly the same as this. We move Statechart and System Dynamic to the left, so everything is inside the frame now. And we have enough room left in the bottom for the bottom of this view area for adding a new plot. You click on the icon, and on click part, we say when somebody click on it, navigate to the view area. This is how it works. So if we run the model now and click on the presentation of each agent, which would be this icon, it navigates to that view area. So it's a pretty straightforward thing. We can look into each one of these agents and see what's happening inside of them during the runtime. That will be very handy for debugging and see how the model works. So the next step would be to add some charts to present the model better. We add some statistics to the population of users that we have. So we're going to count the number of the agents who are in the using state. For referencing the population, we use the item. So it works like a loop. It goes through all of the states in the using state and counts them. So AnyLogic would generate a new function for us with the same end using name that we can use in our charts. So in the analysis panel, we are adding a time stack chart, and in the data part of it, we will have two parts. The first part would be the number of agents or users who are in the using state, and the second part would be the number of users who are in frustrated state. So we point to the users population and we say, show me the number of the users who are in the using. In this part, we say from all the users size, which is the total number of users, you subtract the number in the using state, which will be called the users that are in the frustrated state. And we're going to update this chart automatically every minute. We are going to keep the last 500 samples. Time window will be 500 to show the last 500 samples. The vertical scale would be the number of users of size for 300. And here, because we want to lay two charts on top of each other, we want to know the position of the chart area and where the chart is exactly. So we set those numbers very explicitly, but if you don't want to exactly set the location of a chart, you can just move it around visually. So this is just a demonstration of how you have access to all the pieces of a chart with numbers. So we set how the chart would look like in a very specific way. So we know exactly where the chart is, where the chart area is. We set the background color. These are all just statics. And if we now run the model, we know throughout the time how many of users are in frustrated states, how many are in using state. As you can see, it reaches a steady state of between 70 to 80 users being using and the rest being frustrated after like 50 minutes or 50 steps. The next thing that we're going to do is to add a chart, time plot, that shows the number of requests that are inside our queue, which means the requests that are not processed yet, waiting to be processed. We call this chart. And these titles will be shown, as you can see on the other one, the queue length. The value would be the size of the queue, queue.size. You can change the width of the color and its color. And we are updating this queue number or queue size every minute. Again, we display the last 500 samples, and the time window will be 500. The vertical scale here still is going to be user size. The maximum number of requests that we can get at each moment would be 300. So that's the logic behind it. And so the line is going to be a step. It's not going to be interpolation. It's not going to be linear. It's going to be stepwise. And here we set the exact same position for the chart and the chart area, so we can overlay these two charts on top of each other. And we put the legend on top. So this is just a way of showing how we can have two charts on top of each other. It might be more representative of the result rather than having two charts. And we do not have any background colors, and if it's transparent, you don't see any background. So the queue length would be on top of the time stack chart now. If we run the model, we can see them both at the same time. You can see how the queue length reaches almost 200 and then it goes down to 0 because many of our users are in the frustrated state, they never come back, and we have enough resources to take care of the rest who are in the using state. Okay. So we want to add a chart, time plot, that is inside each user and shows its satisfaction level for each individual user. So it's not going to be at the population level, it's going to be at user level, at agent level. So we will have 300 of these charts. So we call it satisfaction, and the value of it would be the satisfaction, the level of satisfaction in the satisfaction stock. We set some of these visual. Again, we're going to get a sample at each minute, but just remember this satisfaction level is a continuous thing. So if you gather more information, like every second, the plot will be different. But we do not need that much of detailed numbers, so 1 per minute would be enough for our cases. And we uncheck the visible on upper level options, so these charts won't be visible on the runtime in the main part. And if we run it, we have this chart, these two charts that are representative of the population. And if you click on each of the agents, you can see satisfaction level on the chart which is specific to that specific agent. So you can get some data at individual level basis. It shows the last 500 samples. The next thing to do is to add the word of mouth effect to the model. So as you could see, if the model so far, there was no mechanism to come back from frustrated state to the using state. Now we are adding 2 internal transitions in both the using and frustrated state to take care of when a user is very happy with its service and convinces another user which is in the frustrated state to go back to be a user. So we call the first internal transition word of mouth, or WM, and it's going to be a rate of 5 per minute. And its action is going to be if the satisfaction level of this agent is above 5, which means it's fairly satisfied, then it sends a message randomly to another agent. And this message is a string with the 2-word great service in it, randomly sent to another agent. So this captures the effect of word of mouth. Interaction between the agents. And we have another transition which is internal and always active as long as we are inside the frustrated state. And it triggers by a message, and that message would be great service that probably comes from another agent in the model. And the action would be it adds 1 unit to the satisfaction level of the receiving agent if it's in the frustrated state. Otherwise, it's not going to work. If you're in the using state and you receive this message, it's not going to affect you. Okay, if we run the model now, we will see that the small number of people who remain in the using state, the satisfaction level goes up and goes above the 5, and they will start sending great service message to the other agents. And as a result, they come back to being a using, but they got frustrated after a while because we do not have enough resources in our service, in the service section of the model. They become frustrated again. It becomes like, as you can see, there is an oscillation. It shows how they become frustrated and go back into the user. The other thing that we can do is to add a promotion to the model. Let's see if we can send promotion to our frustrated users and try to make them being user again. For doing so, we go to the controls palette. First, we add a transition inside the user agent that captures when we receive a promotion. So this internal transition would be named promotion effect, and it's going to be based on a message. And the message is promotion. So we need, and when you get a promotion, your satisfaction goes up by 5 units. So it's going to be very effective in turning a frustrated user back into a using user. Here, we add a button from the control panel, and this will triggers sending the promotion messages. We label it promotion. You can see that label is shown on the button itself, and the action would be to deliver to all the agent inside this environment a message, and that message would be promotion. We show just a little bit before that how this promotion, whenever it goes into this transition, it triggers its action, and our satisfaction of the user will goes up by 5 levels. And now if you run the model, we can click on the promotion button and send those promotions to the agents. So I will start clicking it. I'm clicking, it's not just one click. You keep clicking it. I'm sending several of these promotions to the users, and you can see the satisfaction level will go up. And although we have our queue level is not going to change that much, so the service is not working, but they are not frustrated because they get some promotion. So we can do this, and you can see when we are not sending promotion, it goes back to that oscillation behavior. The last thing that we're going to do is to add a slider that can change the capacity of the service. We are going to link it to the capacity of that delay which we named its service. And it has a minimum value of 0. The maximum could be 300, like we have 300 technicians for 300 users. So now we can define different scenarios and see what's going to happen if we change our resources, the number of resources that we have to handle this process. For example, we started with 6, with 60, and we saw that we have this oscillation pattern. We can move this slider to 160 technicians, and as you can see, everybody is happy with the service now. There's no queue of unserviced. And if we go back to 338 technicians, as you can see, we have like 200 frustrated users now. And the queue is low. The queue is low because we have too little of users now. It's not because we are handling things well. And you can see different scenarios by changing the numbers in this slider. Okay, thank you. And so I'm going back to the model in AnyLogic, and I just want to touch into some of the small stuff that might be helpful in you understanding the model a little better, because the model building process was on real time, but it was a little bit too fast, I know, but I'm going to explain some part of it that might be a little bit vague. So as you can see, one of the main objective of this model was to use two methods at the same time to have a more natural construct. And we did that by connecting the system dynamics part to the state chart. And the way we did it was to connecting the flows of this system dynamic part of the model to the state that we are in the state chart. Satisfaction gain level will be satisfaction gain rate is dependent on the user being on the working state. Loss due to waiting will be related to the user being in the waiting state, and gaining loyalty is tied to being in the using state. Also, we have the connection between state chart and system dynamic. These two transitions are looking into the satisfaction level and change and activate these transitions. For example, if your satisfaction level goes below -10, you move from the using state to the frustrated state. And so one other part that we touched was there was some message passing between the state chart and the process of handling the request in the main, which is the process of how the company handles the request for the service to be restored. And this is done by inside these two transitions. Whenever we are going from the working to waiting state, we are building a new request, and so this refers to this specific user. We put this inside of that new request, and we send it to the enter block in the main, which is here, enter block in the main. And this request, we're going through this process, and it will be queued in this queue, and then it will be serviced based on our available resources. And whenever we are done with servicing that specific user's request, we send back a message to that user, which is a string called completed, and this string will be sent to the state chart, and whenever we receive this completed string, we will go back from waiting to working state. One other thing that's worth mentioning here that it's done automatically by AnyLogic was that there is a connection construct here by default in each new user that you build. If you look at this, it basically tells you how the interactions or interface between the agents work, and how you can handle the messages that comes to you, or if you have a connection with other agents to a network. So here, by default, AnyLogic sends any message to the state chart. So this, as you can see, the state chart is check marked. So it means that automatically all the messages that this completed message or these create service message will be handled with the state chart. It will be sent through the state chart and go through all the different parts of it. So there's also another thing worth mentioning is that so the promotion button sends a promotion message to the users, and this promotion is sent to all the users inside, delivered to all the agents inside. Let's see how it works. So as you can see, if you click on the main and go to the properties, you see there is a section called space and network, and the agents that are inside our network now are these population of users. So all of these messages will be delivered to the users that are inside the environment. And we built this environment, we made some changes to the wizard when we built the population of agents, and we changed the width and height from 500 to 400, and we choose the layout of random for our agents. We can change it to a range, for example, to see here. So whatever we did on the wizard, we can change later on in different parts of the model. So if I run the model now, and you can see that the agents are laid out in an arranged layout. And one small issue that we talked about during the model building, but it's worth mentioning again. Whenever you are inside an agent, population of agent, it's agent time. When you're inside and you add a new presentation or a new chart, if you, for example, let me show you. So if I add a new circle from the presentation panel here inside that agent, and I run it, it shows this circle, 300 of those circles in the runtime. We do not want that. We want this to be only presented inside that specific agent. For doing so, we are going to uncheck this part that says visible on the upper level, which would be name for this population of users. So if we uncheck it and we run it again, you can see that that circle is inside each of these agents, but it's not presented in the upper level, which is the main. This is the same thing that we did for this chart inside this agent, and we uncheck the visible on upper level. So I guess these are the small parts that I wanted to cover. Now I'm moving to some of the questions, and I'm trying to answer them as much as we have time now. The first question is, what does X and Y mean in an environment? This is just a way of having the coordinates to show where things are. So, for example, the user. So when I start building this user and this one presentation, which is just showing one of the presentations of the agents in this user's population. I click on it and I said move this presentation to X of 150 pixels to the right and 50 down. So in AnyLogic, y-axis is in a reverse direction that you usually use it because this is the origin, so this is the y-axis, this is the x-axis. And I draw the agent with offset to this position, so all the replications that you see here will start from this point. If I uncheck it, it still considers it to be here at the origin. This is this part. And there are some other questions that probably needs more time, but I guess I can touch some of the other questions. What is the purpose of the request agent? The purpose of having a request agent is inside the request agent we have, so it's this agent type is not going to be working exactly like an autonomous agent that has behaviors and all of those stuff. It's just a package. It's like a wrapper to be saves some pieces of information inside to pass. So this is a request that has one variable inside of that captures which user is sending this request. And here, when we are building that request in this part of the model, when we are adding a new request, we pass the request sender or the agent who sends the request to that request. We put it inside the variable that was inside the request agent, and then we have a package, we call it request or request agent, that will be sent to the enter block in the main part of the model. And it then, that request is going through this process and will be processed during the model. Let me see. And the next part of the question was why do you connect it to the user agent in the way you have done? So I guess if I understood the question correctly, this question talks about this user parameter inside the request. This user parameter is just a pointer that is like a label that we know that this request is coming from that specific user. It's very important for us because when we are going through the process and we are resolving that process, at the end we want to send a message back to the original user saying that your service is completed, and we should know who sent that request, right? So for doing that, we are accessing the user parameter inside that request, and inside that user parameter is it points to the user that sent us the request, so we can send the completed message back to that specific user later. So there is another question that asks, why would you use system dynamics here instead of just statistics continuous? Or some statistics just have a statistics that captures the, a discrete type of capturing the user satisfaction. For example, at 1 unit per time. But what would be different is that adding, so for example here, this is a rate. It's a continuous thing. Its value would be 1 per minute, but it doesn't mean that if we stop the model at time point 5, we have a 0 satisfaction level. The satisfaction level would be a continuous, and at time point 5, we have half of that rate being inside the satisfaction. So if I run the model, you can see that the satisfaction level is actually a continuous number, not a discrete one. So it has, you can see that by the decimal points, it is not just 1 per minute. It could be a base, because during the runtime, the runtime is also continuous, so it doesn't jump into the next step. So we can capture the effect of the satisfaction level on continuous basis. But this is just one way of doing it. If we, for example, think that having access to a continuous satisfaction level is not going to be helpful, we can design it differently as well. This is just an example to show how the system dynamic construct works with the discrete part of the model as well. So there are some other questions, but I think if I start answering them, we probably go over the time. And okay, our time is up for today. Thank you very much for attending the webinar. I sure hope you enjoyed the webinar. Don't forget that you will receive an email from GoToWebinar. Please fill out the survey. Filling out the surveys will be very helpful for us to frame the later webinars to be more towards what you need. And keep an eye out for an email from AnyLogic in the next few days, which will contain the report webinar, model source code, and step-by-step instruction. And if you have any questions, please do not hesitate to contact us. And thanks again. We'll see you soon.